How to balance equations. Balancing equations can be difficult for the first-time student or for anyone trying to learn. So in this short video, I'll go over the few steps on how to simply and easily balance an equation. Some equations, like this, that include oxygen can become more difficult. So we'll start out a little bit easier, and then we'll work our way up to this equation. When working on solving and balancing an equation, the first thing that you should do is balance all metals first. When you have the metals balanced, it makes it easier to see, and the metals, they can't be complicated on either side with diatomic molecules. The second step is to balance the nonmetals, except for hydrogen and oxygen, which you'll want to save for last. Hydrogen and oxygen can become more complicated because of their diatomic molecular nature. So we'll save those and balance them last. First, I'll start out by balancing an easy equation, which is potassium chlorate yielding potassium chloride and oxygen. So the first thing that I do when I'm balancing an equation is I pretend that I am a karate ninja. Hoi-ya! And I karate chop right down where the yield sign is. We could even draw ourselves a little karate ninja over here on the side. Karate ninja, ready to save the chemistry world. Hoi-ya! So what you should do is count the number of atoms that you have of each different part. And remember what I said before about balancing the metals first. So I know that potassium is a metal. It says it on the periodic table. It's part of the alkali metals. Potassium. It has one atom. And on this side, on my chop karate line, this potassium also has one atom. Then, after I balance the metals, which I did, I'm going to balance the nonmetals. The first nonmetal I see is the chlorine. So on this side I have one, and on this side I also have one. Lastly, we're saving the hydrogen and oxygen for last. Not having hydrogen in here, we do have oxygen. And you can see that the oxygen makes it a little bit more complicated, having subscripts that are different. What needs to be done is to find the lowest common denominator for oxygen on 3 and 2, and then we'll make both of the oxygens equal that number. So for 3 and 2, the lowest common denominator is 6. So I'm going to make there be 6 oxygens on this side and 6 over here. Remember, the numbers can only be written in these spaces for the coefficients. So in order to make this oxygen 3, I'm going to put a coefficient of 2 here, and I'm going to put a coefficient of 3 here. So 2, it distributes out to all these things. So now I have 2 times 3 equals 6. Oxygen, there are 6. On this side, these two multiply together. Oxygen is 6. Even though you think you might be done, it's always best to go back and double check. Because of the distributive properties of the two, the coefficient, into K and Cl, the K now over here has 2, and this K has 2 as well. So I'll just erase that and make them equal 2, like it says above. And now we're unbalanced. I can tell from on this side. I know that if I have 2 K's there, to multiply and put a 2 here for the coefficient, so that'll equal 2. And now we have equal to both out, and I always put a check mark to make sure that I know I'm finished. That is an easy way to do a fast one, but now let's get to a harder one that has no metals and has hydrogen and oxygen in it. If at any time you are confused, feel free to pause the movie, go back, and watch it again. Alright, here I am with the harder one. Now this one makes it more difficult because, like I said, oxygen is diatomic. Remember your 7 diatomic molecules: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. Alright, again, we can only put numbers in these spaces. 1 is not needed because we can assume that there's a 1 there. So I'm going to be my little karate and chop! Ha-ya! Right there where the yield sign is, so that I know things must be balanced on this side and this side according to the law of conservation of mass. All right, check metals first. but there aren't any metals in this, so we're going to move on to nonmetals, saving the hydrogen and oxygen for last, which means that I'm going to start with carbon. On this side, I just have 1 carbon, and on this side, I have 6. So the easiest thing to do is going to be to multiply 6 on this side by putting a 6 for the coefficient. Next, I'm going to move on to hydrogen, and I choose hydrogen over oxygen because oxygen is here by itself. If hydrogen was by itself with just H2, I would choose that one, but since it's oxygen, I'm going to use the hydrogen first and save oxygen for last. Let's check how many hydrogens we have on each side. This side I have 2, and this side I have 12. So that makes it really easy for me to figure out that I should use the lowest common denominator, which is going to be 12, and you can multiply this. In order to get 12, I'm going to multiply it by 6. So now I have 12, and the 6 goes here as the coefficient. Lastly, it's time to check the oxygens to see where we're at. Here I have, remember the distributive properties, I'll switch over to different colors so that we can see it more clearly. The distributive properties where the 6 goes through this and this. So here I have 12, but I also have oxygen over here, and I have 6. Which together equals 18. Here I have 6 oxygens, and I haven't written anything here, which does not mean 0, it just means 1. So I'll write 6 right there. And I want the final number to equal 18. So in order for the final number to equal 18, that means I'm going to need 12. And to get 12, I would not put a 12 here because of the 2 in the distributive properties. So I'll put a 6 right here. And 6 times 2 equals 12. So adding that all out equals 18. So I'll go back and check. I have 6 carbons. I have 12 hydrogens, and I have 6 times 2 is 12, plus 6 is 18, and I have 6, and 6 times 2 is 18. So that one is also completed. Thanks for tuning in. If you have more questions, please post in the comments below.